Okay, so now we'll take a look at an example using exponential decay. And here's the information that's given. The value of a new vehicle is $21,500. And then usually what happens for almost every single vehicle, there's what's called depreciation. Every year or every so often, the car goes down in value for various reasons, age, mileage, and so on. In this case, due to depreciation, the car loses 12% of its value each year. So on part A, I want to write the equation for the value of the car after T years. So on part A, my equation should look like this. Y is equal to A times a quantity 1 minus R, all of that raised to the T power. We just need to figure out all the different parts of the equation. So remember, A is the initial or starting value. So in this case, A was the value of the car to begin with, 21,500. R is 12%. That's a percent decrease, but I want to change that to a decimal. So I divide the 12 by 100 or just move the decimal 2 places to the left. So as a decimal, that'd be 0.12. And then T is the time in years. We'll actually calculate the value of the car in 6 years on part B. But then on part A, your equation or my equation should look like this. Y is equal to A, again, that's 21,500, times a quantity 1 minus, we change the percent to a decimal, so 1 minus 0.12, all of that raised to the T power. And then what I'm going to do here is just subtract the 0.12 from 1, and then that's 0.88. So what that means, not only does a car depreciate 12% each year, what that also means, since this is y equals a times b to the x power, the 0.88, that's 88%. If the car decreases in value of 12% each year, that means the car is worth 88% of the value from the previous year. So all these numbers are really connected. But this should be the equation, what I just underlined here, for part A. And then part B, I want to use this equation, again, that I just underlined, to figure out the value of the car after 6 years. So now I'm going to plug in 6 for T. And my equation looks like this. Y is equal to 21,500 times 0.88, now to the 6 power. I could really use this equation to figure out the value of the car after any number of years, after 12 years, after 8 years, something like that, even after something like 5.5 years. But kind of like we've done with all our exponential functions, I can enter in exactly what I wrote down on my calculator. 21,500 multiplied by 0.88, and that's raised to the 6th power. If I enter it in like that, my calculator will do my order of operations. Really what it's doing is taking the 0.88 to the 6th power first, and then multiplying that by 21,500, because exponents come before multiplication. And so what that's equal to, it should definitely be less. If the car is depreciating in value, that means it's going down in value. So once you plug things in your calculator, you know you're doing things at least somewhat correctly if you come up with a number smaller than 21,500. If you come up with a number larger, oh, you're doing something incorrect. But here's what I come up with. $9,984.68. I'm going to round that to the nearest dollar, $9,985. So car went down quite a bit less than half its value after 6 years.